Okay, so we're going to look at concept application 2.3, and we are going to do another problem where we're going to break the force that we're given here from its X and Y. Wait a second. Determine the magnitude of the force and the angle theta it forms with the horizontal. So this time we're given the X and the Y components, and we want to actually find the force, okay, this time, or the, if you would, the resultant force, or the one force that would replace those two. So we're going to start out by drawing our diagram. Okay. Right, and we have an X and a Y component. So I'm going to first draw my X component, and that is 700 pounds. So this is going to be Fx is equal to 700 pounds. So it's kind of like we're doing this problem backwards from the previous problems when we were finding the X and Y components. So this is Y, this is X, and our Fy is equal to 1,500 pounds. Okay. And what we want to do now is we want to find the resultant, or the force that would be equivalent to the X and the Y's, okay? So we're going to draw a horizontal line through the endpoint of our Y and a vertical line through the endpoint of our X. And the intersection created there is where our force is going to start at its tail, and its tip is going to point to that intersection, and we'll call this F. Now, F is going to represent the magnitude of that force, and then we're going to use the angle theta to represent the angle that it's going to be at to the horizontal. So we want to find F and theta. Okay. Now, as we look here, because these are on the X and Y axis, we know that if we look at either one of these triangles, right, this is a right triangle, right? And this length is an equivalent length to Fy. Don't float Fy out there, all right? But we can visualize that and see that. So we've got a right triangle, and we want to find the length of the hypotenuse, and we want to find the angle theta. Ideas, where we start. What do we want to do? You guys tell me. You get to drive this one. What about tangent, Nia? Yeah, look at in the example, they're doing tangent theta. So what are they trying to calculate with that tangent function? Theta, right. So yeah, let's go ahead and calculate, determine what theta is. So since theta is here, it's unknown. This is the angle where it is, if you would, we have the leg X and the other leg Y. So they're choosing the tangent function because we've got the side opposite, which would be the Fy, and we have the side adjacent, right? We don't have the hypotenuse yet, so sine and cosine aren't available for theta, right? So we can say tan theta is equal to side opposite, which would be our Fy, divided by our Fx, which is equal to 1,500 pounds divided by 700 pounds. Pounds cancel. And our theta is going to be, what do you got? About 65? Yep, 64.98. Yep, 65 degrees. Okay. So that's one of the answers that we need, right? Now we've got to find F, right? F is the hypotenuse of this right triangle. Now there's like multiple ways that we could calculate this, right? But try to use as much given information as possible. What do you think? Pythagorean's theorem, exactly. Yes, because Pythagorean's theorem, if we use the length of these two, which was given, Now we're not using any calculated information, right? You could say, well, we could use the sine function or the cosine function using the 65 degrees. But remember, 65 was calculated. So I'm not saying it's not a good number. Confident in it. It's a good number. But in the event it wasn't quite right, you want to avoid that. So yeah, let's use Pythagorean's theorem to find f. So f is going to be equal to the square root of fx squared plus fy squared, right? Okay. So now putting our values in here, it's going to be the square root of 700 pounds. Make sure you put your units in there. You could put lb if you wanted to, plus 1,500 pounds, and that both of those are squared. What do we get for a force? You get 1,655 pounds. Now, again, you'll notice that on your calculator, you're getting 1655.2945, blah, 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 right? This is 1,600 pounds, right? 0.5, 0.2, 0.3 is kind of insignificant, right? So going to the whole number is a good thing to do. Thank you, Matthew. You got the same thing. Now, for this to be your final answer, we're putting a box and or a circle around. Only put boxes and circles around your final answers. Like I said, a lot of times there's going to be intermittent answers along the way, but this is just asking for what is f, what is the magnitude of f, and what is the angle. And as we look up here, make sure that you show the arrowhead going up and to the right because that completes the direction of force F. Okay? All right. Okay. So that is concept application 2.3. Any questions on this one? No. All right, we have one more problem to do this evening, and it will be our last problem that we do tonight. And it is going to be problem 216, all right? And that is going to actually be from the homework-ish. Hold on. So if we look at our homework, I'm going to look there first, so it kind of makes sense what we're doing. So if I go to Module 2 application problems, okay? You're going to be doing, oh no, I'm sorry, not the problem, not that, the practice problems. You're going to be handing in practice problem 224, okay? 224 uses problem 216, which is finding the components. So we're going to kind of do the first part of that problem. So I'm going to go underneath here and it'll make more sense in just a little bit. For your practice problems, you are required to do problem number 224, which is on page 36. It says determine the resultant of the three forces in problem 216. Okay. We haven't done this yet, and we're not going to do it this evening, but the first part of these problems is to break the forces into their X and Y components. So if we turn the page over, problem 216 is on page 35. And what we're going to do is, we are going to find the components of the three forces here, which is going to help us in the first steps of practice problem 224. Does that make sense to everybody? So we're kind of doing like part one of it. So go ahead and get out a piece of paper. And what we're going to do is we are going to find the components of the three forces that are here. So first things first, we're going to draw a nice generous X and Y axis with each one of these forces on it. Okay. So I'm going to go underneath here. I am really not kidding when I say this. half the sheet of paper. I know what's coming in the problems that are coming, and we're going to have to add labels and all that kind of stuff. So when you draw your X and Y axis, there is nothing small about this. They make paper every single day. So use literally half the sheet of paper for this first diagram, okay? So we're going to draw a nice generous half of a piece of paper, okay, in the vertical here for our X and Y axis. So if I look at my piece of paper, this is how big my X and Y axis is, okay? I don't want anything smaller than this. All right. And this is actually problem, okay? We're going to label this 224, all right? Just because it's the first steps, because this is finding the components of 226. So don't label it, I'm sorry, 216, label it 224, because this is what you're going to be, this is what you're going to be handing in. Okay, so now our first vector is going up and to the right, okay? Now they haven't labeled it anything, so we're going to call this F1, and this is going to be 800 newtons, okay? Then we've got, call this F2, and this is 408 newtons. And then we've got F3. Okay. And this is going to be 424 newtons. Okay. This is our Y. This is our X. Now, we are going to, you'll notice that on the problem, okay, all of our dimensions are in millimeters, okay? So this is 800 millimeters, 600 millimeters, 480, 560, and 900, okay? These are the distances, so we can calculate the angles that these are at. So what we are going to do is, for our first angle here, we're going to call this theta 1, okay? For our second angle to force 2, we're going to call that theta 2. Okay. And the third angle to force 3 is going to be theta 3. It's going to be this angle right here. Okay, make sure you get that one. They're all going to be from the x-axis. Okay, from the x-axis. Now what we need to do is we need to determine what those angles are based on the distances that were given. So let's go ahead and draw in the dashed lines here. And we know that this horizontal line, and this is where I want you to label out here, this is 800 millimeters. And this is 600 millimeters. Do not put those on the X and Y axis. We want those on the dashed lines. Okay. And then I'm going to do the same thing for my theta 2 and my F2. So my F2 is 900 millimeters vertically and 480 millimeters horizontally. I know they should be at the same height, but that's not the way they came out. So make sure you use the 900 millimeters vertically for F3. And I'm going to sneak this one in here, 560 millimeters for the horizontal, okay? So now we want to calculate each one of those angles. Looking at theta 1 to start. The position of theta 1. If we go side opposite and adjacent, notice we can use the tangent function to find theta 1, right? So if we go down here, tan theta 1, make sure you put the 1 here and that it's up here, is going to be equal to the side opposite, 600 millimeters, divided by the side adjacent, which would be parallel down here. So it's going to be 600 millimeters divided by 800 millimeters. So theta 1 should get the 36.9 degrees. We're just going to put a little cloud around there or a line underneath it. Don't put a box around it or a circle around it because it's not a final answer. Okay. Now we're going to do the same thing for theta 2. Where theta 2 is positioned side opposite over adjacent, which is parallel to the 480. Okay, so side opposite, if we say tan theta 2, we're going to have the 900 millimeters divided by 480 millimeters. Millimeters cancel, right? So theta 2, what do you get? 61.9. Okay. And then go ahead and calculate theta 3. Okay. So for theta 3, you should get 58.1 degrees. Okay. All right. That was an intermittent answer because we need those to really calculate what we're trying to get at, which are the components, right? We need the angle that each one of those forces is at. So the next thing we're going to do is we're going to calculate the components of each one of those forces. So we're going to go up to F1 to start off with. And we are now going to draw in the X and the Y components. So slightly above the X axis, I'm going to draw my F1X. So it's F1, the X component. And then this one, it's the only one on the Y axis, so it can be right on there. I'm only offsetting it a little bit because I know I'm going to have another one right below it. And then you've got an F1Y. Okay. So let's calculate these components first before we add the next ones, okay? So if we look at F1X, we know that it's at an angle of 36.9 degrees, right? It is the side adjacent, and we know the hypotenuse. Which trig function is going to help us find the magnitude of F1X? Cosine, yeah, absolutely. So cosine of 36.9 degrees is going to be equal to F1X divided by its hypotenuse of 800 newtons. Okay. So this is the minimum you need to write out for me. All right. And if you then kind of like, oh, okay, I'm going to multiply that up and I'm going to calculate F1X, that's totally fine. I just want to see this to start. That's like the base, if you would. Because if you don't get the right answer, then I can at least look here and see maybe where the problem started. Okay. So I'm gonna do that very same thing. So F1X is going to be equal to 800, 36.9 cosine multiply those together. So you should get 639.7 newtons. Okay. Now, you might say, well, the problem's asking me for the X and Y components of each one. Don't put a box around this because remember, this is like the first part of our problem 24, which we're going to be using this. So we're just going to go like this. We're going to put our little cloud around there so that we can always reference back to it. Okay. Now let's do our F1Y. Our F1Y has an equivalent length over here. So with that angle theta 1, the 36.9, Fy is the side opposite. And we're going to use the hypotenuse. So that will be the sine function. So sine of 36.9 is going to be equal to F1Y divided by 800 newtons. And then F1Y should be 480. I'm going to do the 0.3 newtons. Just because later on we are going to be using these numbers. They're still in the problem, if you would. Okay, so then what I'm going to have you do, find the X components for F2 and the the X and Y for 2 and the X and Y for 3. And then we can compare. Make sure that you draw them on your diagram. And this is where, especially when we have multiple ones coming together here, this is where having enough room becomes really important. Okay. Trying to get these last two on there. So it's these two and then those two. So for F2X 192.2, F2Y 359.9, F3X 224.1, and then for F3Y 360, it's 359.96, so it rounds to 360. Okay. So I think there's a couple people still finishing up, but for those who have finished, did you guys get the same numbers as me? Right. Now, thank you, Matthew. Now, diagram-wise, these are our numbers. Diagram-wise, you're going to notice that up here on that same diagram, I added my F2X, my F2Y, okay? And then F3Y next to it. So I could kind of see there was a division there between them, okay? So that there's two forces here. So I went slightly off of the axis and then F3 went to the left, okay? Remember, we're not putting positives and negatives in these numbers here. Yes, they might be pointed down or to the left. Don't add the negatives. We will worry about that in our next steps, okay? But this is components of those forces that don't lie on the X and Y axis. Okay. All right. Are there any questions on the things that we went over? Kind of at the beginning, we looked at resultants of two forces using the sine and the cosine laws. Okay. And then now we've looked at breaking forces into components. The next time we get together, we are going to be looking at using these components to now take it a step further and solve for resultants of more than two forces, okay? When we have threes and fours and such, and finding the one force that's going to replace all those and have the same net effect on the body. So that's what we get to look forward to on Wednesday, right? So for tonight, let's take a peek at where we are at. If we look at, I have our practice problems here, all right? What we have done is we have done the practice problems through concept application 2.3, okay? We got started on problem 224, okay? That's what we just got done with, but we still have more to do to finish that one up. So we basically have 4 more problems as we look here to finish up the items that we're going to be looking at here in Module 2, and we will be doing that the next time that we're together. Right now, you would be ready to get started on some of your problems. So if we look at the Module 2 application problems, the problems that you will be ready for are through 219. So the first half here, so 2.1, 2.5, 2.7, and 2.18. Those would be the problems that you are ready to get started with the information that we've gone through. So if you did want to get started on the application problems here, those would be ones that you could target, okay? And then the next time we get together, like I said, we'll continue on, and then we'll be able to, by the time we're done with our next lecture, finish up the rest of the problems here, okay? All right, so that's all that I have for you this evening. I'm going to stop our recording at this time.